While other countries are still arguing over paperwork, China has already finished building hundreds of mega projects at the exact same time. Think about that for a second. Not one project, not 10, hundreds simultaneously. Highways that climb above the clouds, solar farms bigger than entire cities, bridges stretching across open ocean, tunnels drilled through solid mountains by machines that never sleep. And here's the part that really gets people. Western engineers, the same ones who built the Hoover Dam, the Golden Gate Bridge, the Channel Tunnel, are standing there with their jaws on the floor. This video is going to take you through 11 of China's most insane engineering achievements. Roads, ports, dams, high-speed trains, tunnel machines, all of it. And by the end, you're going to understand something most people haven't figured out yet. China isn't just building infrastructure, it's building global power, one mega project at a time. Let's start with roads. China has the longest highway network on the entire planet. Over 177,000 kilometers of expressway, more than the United States, which has been building highways since the 1950s. But the number isn't even the crazy part. The crazy part is where they're building them. The G4218, nicknamed the Cloud Highway, runs from Chengdu all the way into Tibet. The road sits more than 4,000 meters above sea level. That's higher than most mountains in Europe. The air is thin. The temperature drops below freezing for most of the year, and the ground literally shakes because of constant seismic activity. Engineers had to drill through unstable rock, so build across deep valleys and work in conditions that would shut down construction crews in any other country. But China finished it. And now one of the most isolated regions on Earth is connected to the national highway grid. How do they build roads that fast? It starts underground. First, a full geological survey. Teams scan the soil, the rock layers, everything below the surface. Then comes deep compaction, where heavy equipment pounds the ground until it can hold millions of tons of traffic for decades. After that, layers of base material go down, followed by hot asphalt or reinforced concrete on top. But here's where it gets really interesting. Modern Chinese highways don't stop there. They embed sensors directly into the road surface. Traffic density sensors, accident detection systems, predictive alerts that warn engineers about damage before a single pothole even forms. These aren't just roads. They're smart roads with a nervous system. And the machine making all of this faster? The Vögele Super 3000, your German-engineered asphalt paver that China has deployed at massive scale. This machine lays wide, thick layers of asphalt in a single pass. One pass, what used to take multiple runs, multiple crews, multiple days, this machine does in one shot. It works through extreme heat, heavy rain, and rough terrain without losing accuracy. Built-in slope control and thickness monitors ensure the surface is perfectly flat down to the millimeter. On a highway where trains of cars travel at 200 miles per hour, even the smallest bump is dangerous. This machine eliminates that risk entirely. Projects that used to take years are now done in weeks. Now let's talk about energy, because building roads means nothing if the lights don't stay on. China's deserts hit temperatures above 50 degrees Celsius. That's 122 degrees Fahrenheit. Most equipment fails in that kind of heat. Most people can't even stand outside for more than a few minutes. But China looked at those scorching, empty deserts and saw something completely different. Unlimited free energy. They built massive solar farms out there. Panels arranged in kilometer-long arrays, stretching so far across the ground they look like mirrors from the air. Smart cooling systems keep the panels from overheating. Remote-controlled software adjusts every single panel throughout the day to capture the maximum possible sunlight. Zero smoke, zero noise, zero pollution, but just sunlight converted into electricity for millions of homes. And then China figured out how to move that electricity across impossible distances. Ultra-high voltage transmission lines, the most powerful in the world, carry energy thousands of kilometers from those remote deserts all the way to the cities that need it, with almost no power lost along the way. 20 years ago, that was a pipe dream. Today, it's completely routine. But energy isn't only solar. Let's talk about dams and what it actually takes to build one. Building a dam isn't just pouring concrete next to a river. First, you have to redirect the entire river. Engineers use massive excavators and earthen dikes to temporarily reroute millions of gallons of flowing water just so they can work on the dry riverbed below. And then they dig down to bedrock and start pouring concrete layer by layer, compacting each one until it can hold back the weight of a full reservoir. Inside the dam, they install turbines, pressure pipes, control chambers, and floodgates. One single turbine inside a large dam can be taller than a 5-story building and generate hundreds of megawatts of electricity in a single rotation. After everything is in place, the river is let back in, the reservoir fills slowly, and the turbines roar to life. Clean, renewable power flowing to millions of homes downstream. No burning, no pollution, no CO2. Now let's go somewhere even more extreme, underwater. Building underwater is one of the hardest things humans do. Water pressure crushes, currents push, tides shift the ground beneath your feet. But China solved this with something called a Fender Marine cofferdam system. Modular, waterproof walls are assembled in sections and driven into the seabed, creating a sealed barrier around the work area. The water inside is pumped out, leaving a completely dry space where crews can build foundations, pillars, and berths like they're on dry land. The system can be resized, repositioned, and reused on the next project. And it causes almost zero disruption to the surrounding ocean environment. This technology is exactly what made the Yangshan deepwater port possible. Yangshan Port sits on an island off the coast of Shanghai and handles over 4 million TEUs per year. That's 4 million standard shipping containers every single year. The docks are deep enough for the world's largest cargo ships. Vessels so massive they make aircraft carriers look like rowboats. And the entire port runs on automation. Robotic cranes, automated ground vehicles, computer systems managing thousands of container movements every single hour, with almost no humans on the floor. The port is connected to the Shanghai mainland by the Donghai Bridge, 32.5 kilometers across open water, built specifically so trucks could reach an island port. That's the level of commitment we're talking about here. And speaking of bridges, the Hong Kong-Zhuhai-Macau Bridge deserves its own moment. This structure connects 3 major economic zones across the Pearl River Delta. It's not just a bridge, it includes an undersea tunnel section where the road dips beneath the water so that massive cargo ships can pass above it. Building this required engineers to prefabricate enormous tunnel sections on land, float them out to sea, sink them to the seafloor with pinpoint precision, and connect them end-to-end underwater. GPS-guided placement, robotic welding, precast components fitted together like puzzle pieces across open ocean. The final structure stretches over 55 kilometers and cut the travel time between Hong Kong and Zhuhai from 3 hours by car to just 30 minutes. And then there's high-speed rail, the project that made engineers around the world stop and completely rethink what was possible. China's high-speed rail network is the largest on Earth, not second largest, the largest by a massive margin. Over 45,000 kilometers of track, most of it built in the last 20 years. The Beijing-Shanghai line alone is 1,318 kilometers. That's 819 miles. And trains cover that distance at 350 kilometers per hour. The trip used to take 12 hours by regular train. Now it takes just over 4. Building this track meant clearing land, analyzing terrain, laying drainage systems, placing stone ballast beds, setting reinforced concrete sleepers, installing steel rails on top, then wiring up the signaling, the power lines, the entire communications network, and testing every single piece of it before one passenger ever steps on board. This isn't fast and cheap. This is fast and precise. And that combination is what shocked Western engineers most. And finally, tunnels. Because China is not just building on top of the earth. They're drilling through it. Forget the old image of workers with pickaxes in dark, dangerous holes. China's tunnels are built by tunnel boring machines, TBMs, as long as a city block, weighing thousands of tons. The front end spins continuously, grinding through solid rock the way a drill goes through wood. Behind the spinning head, a conveyor belt carries the broken rock away. And right behind that, precast concrete wall sections are installed automatically, lining the tunnel as it grows. No stopping, no brakes, or just continuous forward movement, deep underground 24 hours a day. China currently has hundreds of these machines running simultaneously, under Beijing, through the mountains of Sichuan, beneath rivers and bays across the country. There are even plans for an undersea tunnel from Fujian province to Taiwan, which would rank among the longest undersea tunnels ever built on Earth. While other superpowers are sitting in committee meetings, filing reviews and debating whether something is even possible, China has already moved on to the next project, building from underground to the sky, from packed cities to empty wilderness, from the sea floor to mountain peaks. Not one megaproject, hundreds, simultaneously, whether you admire it or you're unsettled by it. One thing cannot be denied. China has completely rewritten the rules of what humans can build. Watch the next video popping up on your screen right now. It's just as wild as this one.